From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker.
And I'm Kaushik Gopal.
Welcome to the show.
If you work on an Android app, and if you're listening to this podcast, I'm going to presume you do, you'll know that when your user reports a problem or a crash, it's the absolute worst feeling. To make matters worse, they might one-star your app, go on Twitter and complain about the app, and if they're feeling particularly merciless, probably go on Reddit or something and post it there. But you know what? They have absolutely every reason to. If you treat your customers basically as an off-site QA team, it's rude to them and it's just bad for business. As developers, we don't want to rely on customers to report errors. Instead, we want to catch this much early on. Ideally, you just have automated tests and these tell you when there's a problem. But, as we've talked about on the show multiple times, that's not always as easy as we want it to be. Because writing tests can be hard. That's why Sentry, our sponsor for today's show, tells you about errors in your code before your customers have a chance to encounter them. Not only do they tell you about the errors, they also give you helpful details that help you fix these errors. For example, how many users were impacted by this bug, the complete stack trace if it's a crash, the commit ID when this error was released, the engineer who wrote this line of code that was busted, that and a whole lot more. If your code is broken, let's fix it together. That's Sentry's tagline. I love it. You can check them out at sentry.io/for/Android. Sentry is a pretty common word. It's actually a pretty cool name for the service if you know the English meaning of the word. But I want to make sure you get that domain name right. It's sentry.io. Once again, sentry.io/for, as in FOR/Android. Check them out today and fix your errors before your users encounter them. Thanks for sponsoring today's show, Sentry.
In the previous episode, we talked about building Lambda expressions as simple variables. And these variables, we could just basically call them inline as functions. They could perhaps perform some type of value calculations. We could kind of use them with other Lambda expressions. We talked about how we could use Lambda expressions with multiple different arguments. We talked about how by default they are of the unit return type. And then we also talked about how we can create a Lambda expression with a known type, such as a string or whatever type you'd like to return it. And we wrapped up the last episode talking about how we can take a Lambda expression and provide it as a function argument to another function. So that's what we're going to talk about today, is providing a Lambda expression as a function parameter to another function. So basically what that means is inside of that function that's created somewhere, I can call a Lambda expression. And if we think about this, what we're really doing is we're saying, hey, function, you're going to take in some parameters and they could be integer strings or whatever types. And then here's a Lambda expression. Basically, we're going to pass in a function into this other function. And we're going to kind of allow it to kind of delegate some work outside of the function, which is kind of cool if you think about calling into a function and saying, hey, when something happens, here's a function that's going to take in a string, and you just give me the string, and I'll worry about how to process it, and then the original function can keep processing after that. And so we'll talk about that, and then we'll also talk about how we can have a return type as a Lambda expression for a function as well. So without further ado, let's get going. The pure thought of having a function parameter, an argument for a function that is a Lambda expression is kind of confusing. You may be wondering, why would I want to provide a expression, a Lambda expression as a method argument? Well, let's use this pretty simple example here. Let's say that you've created a log reader class or a file reader class. I mean, we all work with files at some point, especially when you start working with large corporations. You have lots of integrations. Some company sends you a file every few days on an FTP server or drops it into some other folder. You have to process that file and do something with that data on a nightly basis or perhaps whenever it shows up. So it's kind of a common thing to process a file. Now, a lot of times when we build these classes inside of programming, we need to process this file, and then we do the 80,000 things that it's supposed to do already. And then a change comes in. So, hey, actually, when this other, and you create a library for it. Let's say that you've created a little library that allows someone in your company to process that file. And then what happens is a change comes in and someone says, hey, well, when this happens, I need you to process the file, take the data also out and do something else with it. Oh, and when you encounter this other line and this type of file, we got to do something different. And before you know it, all of the requirements explode and your file has a ton of arguments. It's like, all right, process this, if this, process that, and it has a bunch of flags inside of the argument list. Mainly because you're doing a bunch of switching inside of there. Now, one way you can actually get around that is if, for example, maybe each time you process these files, you need to do the same thing like 80% of the time. It's that 20% difference, kind of the basic Pareto principle, the 80-20 rule. 80% of the time, we're doing something the exact same, but 20% of the time, I need to do something before I process the file or in the middle of the file or on each line or at the end of the file or when I encounter these weird scenarios. So how do we kind of do that and not kind of pollute this library up? One of those ways that you can do that is with a function parameter using a Lambda expression for that function parameter in Kotlin. And so let's have a class called logReader. And this logReader class is just going to have one method now. It's going to call process file. And this method is going to take a file that you want to process. It's going to read everything line by line. And then what it will do is on this code that I have here, which will be in the show notes, it has for each line that it encounters, it will print the number of characters. Let's say that's a requirement for some reason. And then at the end, it'll say, for each line, it'll say done processing the line. Now, for whatever reason, you need to do something with that line. And let's say perhaps you need to save that data to the database, and you could do that. That's already built into your logReader class. But for some reason, each time the line is processed, you need to let the caller of that class know, hey, here's the line that's being processed, and kind of delegate responsibility to them, saying, hey, here's a string of the line of that file. Do whatever you want with it. And then you pass that delegation off to the caller. How do you do that? Well, that's basically by providing a Lambda expression. And so inside of this, I have a function called process file. Again, it takes a file that I want to process. It's going to go either over each line. Now I can provide another parameter here, and I'm going to give this one a name of process line. That's the parameter name, colon, and then I'm going to provide a Lambda expression. It's just going to take in a string, so open parenthesis, string, close parenthesis, basically saying, hey, I have a Lambda expression. It's going to take one parameter that's the type string, and that's going to return a unit, which is basically the default type here, and says, hey, it's not going to do anything. It's like void, similar to void in Java, and it's just a single arrow to the right hand side, unit. And then what I'm going to do here is, knowing that not everybody's going to want to process every single file, sometimes I'm going to give it a default implementation, so a default argument implementation. That's just going to be equals open and close curly brackets. Now what this allows me to do is, anytime I want to call the process file method, I do need to give it the file to process all the time, but if I would like to, I can also pass in a Lambda expression as a second parameter that will give me basically pass me each line as it's processed, that I can do something with it. So what I'll do is I'll maybe create a new instance of this logReader class, and then I'll say, hey, logReader dot process file. I'll give it a file that it needs to process, and that could be just some text file. And then after that, I'm going to give it the next parameter, and that's just going to be open curly brace. And then inside of the open curly brace, by default with Lambda expressions, Kotlin will give you a variable for free, and it's called it, just it. And that's going to be of the type of that Lambda expression parameter, so whatever it's being called. So in this case, we're getting a string variable in there, and that's just called it. And that's only when we have a single parameter. It's called it. Otherwise, we need to specify some names here for that. So we have an it parameter, and again, I could rename this if I would like to, but we'll just go with the default. Inside of that Lambda expression, I can do anything with it, and that it is going to be the line. Each one of those lines in that file, this Lambda expression is going to be called each time. So in this Lambda expression, I might just call the first 10 characters of that line. I might print it to the screen, say print the first 10 characters of that line, and I'll just print it to the screen using the println command. Now, when I run this and I decide to process a file, what's going to happen is, when the file is open, each line will get read by the process file method. And inside of that method, I have a regular, again, this is kind of in our logReader class. Each time I process the line, I'm just going to print out the number of characters in that line. So, hey, here's the number of characters. And then at that point, I'm going to delegate to the process line Lambda that we are talking about, that we just built. that's going to pass it off to whoever's calling it. And if there's an implementation of it, then it will use that. Otherwise, it will use the default implementation that's provided in the argument list, because we're providing a default argument here. And then at that point, when that line is done processing, it'll say line done processing at the end. Now, so if I have 10 lines here, I'll basically have 10 iterations of number of characters, and then whatever my Lambda does with it, and then line done processing. That'll happen 10 times over and over. It happens for each line. And so again, this is kind of hard to explain, again, over an Audible format. Take a look at the show notes. You'll see an example here of the log reader class. But what this allows you to do is then at that point, inside of your Lambda expression, you can do anything you want with that string. That's going to be that line of that file. So it could be a header of a file. It could be the next line, whatever the processing point it is, you could do something with it. Now, also here's a cool thing is maybe you only want to process every third line. And so you could put that logic inside of your log reader class for whatever reason. You could say every third line, and you can provide another argument inside of your process file method. And that would allow you to call that every third line as long as you had that logic built into your log reader class. Now, I'm sure you can imagine that there are lots of places and lots of things you can do with this, and that's correct. That's kind of the power of this, is we're allowing to delegate, some responsibility of what's going to happen in this method to somewhere else, to the caller, and allows you to actually provide extension points inside of your application, inside of your library, to do something with various different components. Now, you do need to be aware that if you're passing around lists, or you need to be aware of your reference types and your value types and how things are passed around. And if you change something over here, is it going to change it inside of the log reader class? So you do need to be aware of those things. If you need deep copies, you'll want to make deep copies. So those are things you'll have to be aware of as you're building it. So that's one thing you can do. You can pass in 1, 2, 3 multiple different arguments inside of a function that can be Lambda expressions, and you can call them whenever you'd like. Again, because these are basically just variables, and you're going to pass them in whatever value you'd like. Okay, now I really want to blow your mind here. Now what I'm going to do is I'm going to take this even a step further so we can demonstrate of how we could have a function return a Lambda expression. Now, we have already covered how you can create a Lambda expression inline as a variable. So we already know that it's pretty simple to just kind of create an inline Lambda expression, and we could have that just returned. And that's going to be covered in the first episode where we talk about Lambda expressions. And that's pretty simple. We can basically say, hey, this function is going to return a Lambda expression that is of type string and integer as parameters, and returns a string from its Lambda expression. And then we could pass in, inside of that function, we would just say open curly brace, name, comma, age, which is a string and an integer, and then provide the implementation of that function or whatever. And that might be, take the age and the name and print some string to the screen. So it's actually pretty simple to return a Lambda expression. But here's where we can kind of do some really powerful stuff with this. So I've taken this a little bit further here. We're going to stick with our log reader example. Now, remember before I said, hey, we may need to process this line. But now maybe we've had a requirement of we only really want to read this file once because it takes forever to read it. So we'd kind of just like to be able to provide many different implementations of this, basic, we'd like to process this line many times, but do different things with it. So how would we do that? Well, we'd need a list of, line processors. And if we think about that, it's just a Lambda expression, and we need to call it, and each different caller will have a different implementation. So maybe I'll create another method inside of our log reader class that calls process file with, handlers. And these handlers are going to be processed per line. And again, we'll pass our file in, but this time I'm going to pass basically an interface in, and that interface has one method on it, and it calls handle line. That handle line method returns a list. Get this, a list of Lambda expressions. That's kind of the mind-blowing thing there. So instead of passing in a single Lambda expression to our process file kind of method, we're going to pass in a interface with had just one function on it right now that says handle line, and that is a list of Lambda expressions. So it means I can have multiple Lambda expressions in there. Now inside of my file processing code, I would do whatever I'm going to do with it. And then when I want to handle each line, this time I'd say, hey, log handler, and that's the instance of my interface. I would like you to handle a line, and that's going to give me back a list of Lambda expressions. And from there, I can say for each. And from there, I'm going to get basically I'm going to loop over all of the Lambda expressions that are inside of my log handler that is going to be processed with my log reader class. And at that point, I can say, hey, give it a name of handler, and I'll pass it the IT, which is the line that we're processing. So handler it. Now at this point, if I want it, when this is running, I could pass in 0 to many log handlers. So it's very extensible here. I can pass in many, and they could just all do different things with this line. One could process it. One could send it to Slack. One could send it this place. One could be this thing over here, because perhaps a file or a line or a log is going to have some pertinent information about it that you need to know about. Perhaps you need to send it to Elasticsearch. Perhaps you need, like I said, send it to Slack if it's an error or a particular type of error that you're grepping out of the string. And then maybe one of them is a SMS notifier. Like, hey, if this thing contains X, Y, and Z, then we need to notify DevOps that something is going on. And so instead of putting all that stuff inside of one handler, you can have many different handlers and stuff it into this interface, which can be built somewhere else through dependency injection or whatever. So let's say we were to build this actually in code. I'd create my instance of my log reader class like I did before. No big deal. I pass in my file I'd like to open. So I'm going to say log reader.process file with handlers. I'll pass in the file. Now in this case, I need to pass in the interface. So I just pass in log handler. It's an instance of the interface. I'm going to create it anonymously in Kotlin, which is pretty easy. We just kind of say log handler equals object : log handler. And inside of IntelliJ or Android Studio, wherever you're at, you'll be able to provide it'll kind of scaffold out the skeleton of that anonymous class. And then inside there, I can just use I can say list of, and then I can pass in multiple Lambda expressions in that list of. List of is a helper class inside of Kotlin collections, which allows us to create a list of something. Type reference is going to help us out here, so I don't have to provide the Lambda expression as the generic type to the list of class, but if I'd like to, I could. So here I'll just pass in 3 or 4 different one of them, which you'll see in the show notes. If this is really confusing, which I'm pretty sure it is, check out the show notes. You'll see how we have each line is printed to the screen. Also, if the show notes, for whatever reason, we got some notes of this, certain podcast players do not render the markdown correctly for the code. So if this is not making sense, please check the show notes or visit the website, and the website will actually render the code correctly, and you'll actually be able to see everything there. And what this is going to do is we'll have a list of these Lambda expressions. That could be 5, 10, 15 of them. And again, these are created kind of inline right now, just hard-coded. You may actually generate these or create them and have them built somewhere in your application that are passed in through dependency injection. So many different places could process this file. You can do all different kinds of things with it. And then again, our API for our log reader class is actually really small and it's really simple. I'm looking at on my code window here. I'm looking at this right around 6 lines of code for this very simple implementation, which just has the file, loops over each line, has one line statement that says start of processing, and then I call the log handler where it processes the line, passes it off to all the different handlers, and then at the end of that line, when it's done processing the line, I just print something else that says line is done processing. Again, 6 lines of code, but now I've made it extensible. If I would like to have another log line reader, I just create that implementation, add it to the list, and it will get processed accordingly, and I don't have to touch anything inside my log reader class. But how that's done is with that log handler interface. The log handler interface has one method called handle line. The handle line method, that's type that it returns is a list of Lambda expressions. And that Lambda expression takes in a string as a parameter and returns type unit. So kind of like a Java void. It's just going to allow us to process all of the lines independently. And if we want to have, each line gets processed by 10 different things, then we can do that. So as we can tell here, there's a lot of cool stuff that we can do with Lambda expressions. Very difficult to describe over an audible format. So thanks for hanging in there if you're still here with me and I haven't put you to sleep yet. There's tons of cool things you can do with it. Lambda expressions really open up a whole different functional paradigm of programming for you. You can start to get into higher order functions, into developing DSLs and all different types of things with these different types of functions, anonymous functions, higher order functions, Lambda expressions. We can go on and on and on. I hope this episode's helped. And if you have any questions, please feel free to drop them into the comments section on the website, and we'll do our best to reply back to you as soon as we can. Thanks for listening.
I want to thank Sentry for sponsoring today's show. Their tagline is, "Your code is broken, let's fix it together." They're a super cool crash reporting service that gives you all the helpful details that you need when detecting and fixing errors in your application. Don't wait for your users to report your errors and crashes. Use Sentry to catch them earlier. Check them out at sentry.io/for/Android. Once again, because Sentry is a common word, I want to make sure you get it right. Sentry.io. My thanks to Sentry for sponsoring today's show. That's it for the show, folks. Fragmented is hosted by Donn Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.